Good morning, everyone, and welcome to another remote lesson. Today we are going to be practicing motion graphs and interpreting motion graphs, and I'm going to give you an example of what you're going to be expected to do for your assignment that is due on Friday, April 3rd by 4 p.m. So, without further ado, let's get to it. All right. So we practiced last week the distance, rate, and time gizmo, and this is a really great, that was a really great introduction to what we are going to be doing today. So the first thing I want to do is kind of just explain the way that these graphs are set up. Distance is going to be my y-axis, and time is going to be my x-axis. Now, I want to edit some things so that it makes it easier for you to understand. But I want you to understand that here at 0, that means I'm at the start line. 0 equals the start line in terms of distance. Oops. So 0 equals the start line or distance, and then 0 for time would be like the beginning of time. So like 0 seconds if you're just doing a stopwatch. As I go up the y-axis in distance, that 200 means that's further away in distance. So like I've ran farther / the finish line. Or we'll say, we don't even have to say the finish line, but just know that the further up you go, the x-axis, the more distance you've gone or farther you've gone. For time, and let's color code these. So we'll do distance in red and we'll do time in blue. So as I go further down the x-axis, it means more time has passed. So understanding that as I go up, I'm moving further away, and as I'm going more to the right, more time has passed. So in this particular problem, it says, every morning Tom walks along a straight road from his home to a bus stop, a distance of 160 meters. So right here is the bus stop. Right at 160 meters. The graph shows his journey on one particular day. Describe what might have happened. You should include details like how fast he walked. So by looking at this graph, I can tell that he started at his house, which is 0. That's his start line. And then we see that he is walking. He walks 100 meters. And then this is a positive slope, so it means he's moving forward. And then it looks like he is decreasing his distance. I know he's decreasing his distance for a couple reasons. Number one, it's a negative slope. So here he starts from 0 meters and he walks 100 meters. And then from here to here, he walks from 100 meters back down to 40 meters. So he gets closer to his house. Does that make sense? So I'm from here to here, he's moving up in distance, further away. And from here to here, he is going down in distance. And it even looks, if you look at it, I wonder if I can, oops. It's not working. Let's try it this way. So I can tell that I'm moving up here with it because it's a positive slope. And here I'm moving down or back towards the start, so it's a negative slope. Then at 40 meters, he continues back towards the bus stop, moving forward because I'm going from 40 meters I'm going from 40 meters to 160 meters. So I'm increasing my distance again. Let's make a note along the side that if I have a positive slope, it means I'm moving forward. That means I'm increasing distance. Oops, I'm a mess today. Increasing distance and time. Whereas if I have a negative slope, it means I'm moving backwards, which means I'm decreasing distance and increasing time. I have to be increasing time because I can't erase time. The graph is going to keep moving forward along the time axis. The only thing that might go negative or might decrease is distance. So one story we could write to follow this graph is that Tom started at his house, walked 100 meters, realized he dropped his wallet at 40 meters, so he walked back to get it. And then he realized he was running late, so he walked a little bit faster to school and to the bus stop and then waited for the bus. I know that he is not moving here because the distance for 20 seconds, from 100 to 120 seconds, he is staying at 160 meters. Now I know he went faster here because the slope is steeper. So he's covering less distance in the same amount of in shorter time, or more distance in shorter time. I can actually calculate all of these points, and that's what we're going to do for down here. So if we use distance equals rate times time, I can calculate his speed for each one of these sections. So for section A, we're going to call this section A. Or maybe we'll call it the purple section, if I can get it to change. It's not going to change. So we'll say for section A, this will be section B, section C, and section D. So for section A, I do distance equals rate times time. My distance that he travels is 0 to 100. So he travels 100 meters. I don't know my rate yet, but it took him 50 seconds to get there. So I need to get the R by itself. I would divide by 50 on both sides. So my R equals 2 meters per second. And I can even write that down here. So let's see if we can actually. Oops. So for here, I'm going to write for section A, he was going 2 meters per second. And I'm only going to put this here to remind me, and then we can write our story. For section B, let's see how fast he was going. All right, for section B, I start at, I go from 100, I go from 100 to 40. So he travels 60 meters because 100 minus 40 is 60. I don't know the rate. And the time it took was from 50 seconds to 70 seconds. 70 minus 50 is 20. 60 minus, or 60 divided by 20 is 3 meters per second. So to get the R by itself, I divide by 20 on both sides. 60 divided by 20 is 3. So for section B down here, I can write he walked 3 meters per second. And let's even specify that he was walking forward and then he started walking backward at section B because, you know, we said he forgot his wallet, and I know that he's decreasing distance. Now for section C, I go from 40 meters to 160 meters. So my distance is, so I go from 160, from 40 to 160, my distance is 120 meters. I don't know my rate, and the time it takes is from 70 seconds to 100 seconds. So the time is 100 minus 70 is 30. Again, I need the R by itself, so I divide by 30 on both sides. 120 divided by 30 is 40 meters per second. So then I'm going to write for section C, he was moving 4 meters per second forward, which makes sense because we know he was going faster right here because the slope is steeper. And then for section D, this one is a little bit more interesting. For section D, his distance is 0 because from 100 to 120 seconds, he doesn't increase or decrease distance. My rate we're trying to figure out, and my time is 20 because 120 minus 100 is 20. If I divide by 20 on both sides to get the R by itself, 0 divided by 20 is 0. So it means that he was going 0 meters per second, which means he was not moving. So my story I could write, would be that Tom starts at his house, which is 0, and walks 100 meters at a speed of 2 meters per second. Then he realizes he dropped his wallet and walks backwards to 40 meters at a rate of 3 meters per second. After Tom gets his wallet, he realizes he is running late, so he speeds up and walks to the bus stop at a speed of 4 meters per second and waits at the bus stop. So let's kind of look at that again. He starts at his house, he walks 100 meters, then he realizes he dropped his wallet and walks back to 40 meters. And then he realizes he's late, so he speeds up to 4 meters per second and gets to the bus stop, which is at 160 meters from his house, and waits there. Are all sections of the graph realistic? Well, are there any points where the time is not moving? Because that would not be realistic. And the answer is no, time is continuing to move as we see. If we would see a flat line vertically, that would mean that time was staying still, and that's not possible. But yeah, yes, this is possible because I could say because time is continuing to move forward while the distance is changing. And it would be realistic. We could say all of the speeds are realistic. If I said that he was going from 0 meters to 200 meters in 10 seconds, that might not be realistic, but this is pretty realistic. Let me show you guys what you're expected to do. And I'm also going to save this and put it up on my website and on the assignments tab so that you guys can see it. So I'll take care of that a little bit later. But let me show you guys what you're expected to do for your homework. So this is already posted in your assignments tab. It's also posted on my website. So here it is on the website, April 1st Motion Graph Project. I'll put our lesson today here as well, and then I'll put the link to the YouTube video here. But if you go to Burley Assignments or Burley's class assignments, it's right here. And you're going to download it and then save it to your computer and edit it. So you're going to write a story for each graph. Use the Motion Graphs Practice video on my YouTube channel. That's this video. Or there's a link on my website's homepage, which I just showed you guys. Hint, one of the graphs is impossible. Tell me which one and why. If you don't tell me why, I won't give you full credit. So you're going to look at these graphs, and you can make up speeds, or you can just kind of tell me if they're going faster or slower. And then you're going to write stories for each graph. You can download this and save it on your computer, then type your response. You can type your response by deleting the lines. See? So if you delete the lines, you can just regularly type. Or you can print it. or write it on a separate sheet of paper and take a picture of it and submit it on Teams. Extra credit would be if you film yourself getting outside and acting one of these following graphs out. You can use the chat on Teams and upload a video. If you go to the chat section and you can, there's like should be a little video tab, or you can upload a video using the paperclip and attach it. Or I've also created a Flipgrid. Let me show you what that looks like, where you can just upload your video and you can use a cell phone to do that. So say you're going to tell me which graph you're acting out, whether you're acting out A, B, C, or D, and then you will put a post by putting a plus, and you'll have to log in with the email, or if you use your phone, I think you should just be fine. But if you struggle with Flipgrid, you can also message me on Teams and submit it that way. So I will give extra credit for anyone who gets outside and acts it out. That's just a little way to keep you moving. If you guys have any questions, you can replay the video. I have live tutoring on Tuesdays at 3 p.m. and Thursdays at 9 a.m. And this assignment is going to be due Friday at 4 p.m. The quarter ends April 8th, and I will not accept any work past that date. So please don't hesitate to reach out if you have questions. I hope you guys have a great day. Stay safe. I love you, and I miss you. Bye.